Over 70% of Earth is made up of water. 97% of Earth's water is salt water. As humans, water needs to be consumed to allow the body to carry out cellular activity that keeps you alive and active. However, water is considered a limited resource. In fact, California is in a state of drought. This is why I propose to look into specific mammals, commonly found in Antarctica, classified under the family of Sphinicidae, also known as penguins. Penguins, as mammals, like us, do not need any more salt in their systems than we do. However, living in areas such as Antarctica, where they have the easiest access to the ocean, which contains salt water, they have adapted an ability to consume the salt water and filter it out from their bloodstream. Penguins contain a specific nasal gland called the supraorbital gland, which removes sodium chloride from their bloodstream. Like its name suggests, the supraorbital gland is located above the penguin's eye socket. This saltwater adaptation can also be found in other birds as well as reptiles. This adaptation to desalinate their own bloodstream is crucial. A penguin's nutrition relies on fishing in the ocean with their beaks. While swimming at such high speeds and opening their beaks underwater, it is inevitable that they consume some of the ocean's salt water. By closely studying the working of the supraorbital gland, I believe that research can lead to the findings of ways to actively filter out salt water from our bloodstream, and potentially find a way to filter salt water in a more productive, less expensive way. Current ways to filter ocean water is extremely expensive, and it requires a lot of energy. Regular water filters are not a solution to desalinate ocean water because the filters are not small enough to separate the sodium chloride molecules from the water. Supraorbital glands were discovered by Knut Schmidt-Nielsen and co-workers in 1957 to 1958 when they observed that sodium chloride had been excreted from the gland in a concentrated form. These glands were found to act in a similar way to human kidneys. However, they target sodium chloride specifically and are much more productive at desalination than our own kidneys. The glands are approximately 1 millimeter in diameter, and they contain a central duct made up of tubules connecting to the blood capillaries. Once blood is carried from the tubules to the gland, cells that line the gland form a separation between the bloodstream and the water containing sodium chloride. By the principles of osmosis, the sodium chloride is not allowed through the cell wall, as the molecules are much bigger than what is permitted to flow through the cell wall. What is left is a separation between salt on one side and water, as well as other small permeable molecules such as glucose on the other side. The leftover solution is then excreted. If we can find a way to mimic the supraorbital gland, we could potentially find a cost-effective and energy-effective way to filter salt water. The possible end result being not so much how do we mass filter salt water, but maybe it's how do we make it possible for us to be able to consume salt water. There's a whole world of possibilities with biomimicry.